And with that, it's my pleasure to introduce Patrice Bourne, who is a Principal Sales Engineer at Robin. Patrice, are you with me?
Yes, I am. Good afternoon.
Good afternoon. Thanks for being on the event. Take it away.
Okay, thank you. So we are going to talk about what Robin Systems does today. And more precisely, we're going to look into our hyper-converged Kubernetes platform to run big data databases and AI and machine learning workloads. And I'm going to start by having a quick overview of what a traditional HCI architecture looks like that probably everybody listening has some kind of experience with, where you have these x86 standard commodity hardware servers where you're going to run some kind of hypervisor, pick your favorite, and this hypervisor is going to allow the system to run multiple virtual machines and thus multiple applications in those virtual machines directly on this hardware. What we do, which is different, is we do not use any kind of hypervisor and we do not use virtual machines. What we're going to do is use the exact same x86 commodity hardware that everybody knows, and we're going to install a Linux operating system directly on top of those machines. And those machines are going to be then connected in a cluster running the Robin software. And what this Robin software does is it's going to use under the cover the standard Kubernetes that you may have heard of to orchestrate the different containers that we're going to use. And we're going to also add features that don't exist in Kubernetes. More precisely, we're going to add our software-defined storage layer, which allows us to do things like being able to run stateful applications on top of just stateless. So for those of you who may not know why this is relevant, if you use standard Kubernetes with Docker, for instance, you are going to have to run or rebuild your applications to be stateless, meaning that they can be restarted without having to remember a given state of when they were shut down or came down. So obviously, all the typical applications that have been written over the years, or decades, I should say, were built way before the concept of stateless was actually being pushed by Kubernetes and Docker. And everything that you've had built over the decades, now you are limited because you cannot run them directly on Docker and Kubernetes. However, with Robin, we can do that. I'm going to explain in a couple slides how we do it. But we're going to be able to actually offer persistent storage automatically, nothing to configure, automatically to all the different containers running on the nodes. And those containers are going to run different applications. And those applications are mapped, or more precisely run, inside pods that Kubernetes is going to manage under our control. The other piece we add to Kubernetes is on the network. And we're going to provide a standardized way of handling the network so that when you spin up or you ask the system to spin up a new container or a set of containers for a given application, we're going to rewire all the IP stack underneath, and we're going to guarantee that even if a container gets restarted and gets moved to another host to be run on, we're going to provide the exact same IP address, and we're going to provide the exact same node name, and all the IP stack is going to be rewired exactly the same. We also do that on the storage layer, which means we can run with Robin stateful applications like database engines or Hadoop. Next slide. So we're using Kubernetes, as I said, but on the next slide, we're going to see what does that mean. So what if your users could bring up an entire cluster in minutes, not weeks? And the way we do this is by providing a user interface where an end user can directly connect to and say, I want to spin up a MySQL database. Couple clicks, boom, you have a MySQL database running. Or I need to spin up a full-blown Hadoop cluster. Couple clicks, you get your Hadoop cluster. Or I need to create an Oracle database because I want to test something. Boom, in a few minutes, you have an Oracle database ready to use. All these applications are going to be run in containers. And if it's a distributed application that requires many services, like a typical Hadoop setup, we're going to create multiple containers, and we're going to distribute those containers on the different machines that constitute the Robin cluster. We're also going to rewire the storage and the network, as I said, and we're going to reconfigure everything so that all the different containers are aware of the other containers running the other services they need, and everything now runs in containers. So there's no virtual machine, as I said, there's no hypervisor, and this allows us to do a few things that are really powerful, like giving a user interface to an end user who does not need to know all the details of the low-level plumbing of how you put these things together on servers. It's just a UI. What we also offer is the capacity to have clusters that may be entirely in the cloud, entirely on premises, or spanning in the cloud or on premises. And you can control, because we control the storage layer, you can control the data, and you can also ask the data to be replicated, for instance, from your machines on-prem to machines in the cloud. And then you can ask the system, when you need to move a container from nodes on-prem where it's running to nodes in the cloud where you want to run next. So this allows you to decide where you want to run a given workload. This also allows you to have a multi-cloud strategy if you want to do that. If you want to have more than one cloud provider, you put this extra layer on top called Robin, and you become cloud agnostic. And you can also provide typical lifecycle management for all your applications with one click. For instance, I need to scale up. So I'm running a Hadoop cluster. I want to scale up and add more HDFS data nodes. Just one click, you say I need another 5, another 10, another 1, another 21. And it's going to create new containers. It's going to configure them to run the data node code, and they're going to join the existing HDFS cluster that's already running inside your containers. We also provide things like being able to take a snapshot of an entire application. So that means snapshot of the data, snapshot of the network layer, snapshot of how the containers are configured. And we also provide, by using the snapshots, features like testing an upgrade. So I want to test an upgrade, but I'm not sure what's going to happen, so I want to make sure I'm not going to break something. You can take a snapshot, ask the system to test the upgrade. So it's going to test the upgrade on new containers that are rewired read-only to the existing data with blocks being created on Modify, but it's going to test the upgrade in a copy on different containers of the running application. Depending on what happens, you're happy with it or you're not, you apply the upgrade or you roll back. We can also do these clones, thin clones. So what happens is we ask the system to take a snapshot and we say create a clone because I want to do something else, but I don't want to damage the existing system that users might be working with. It's going to create a new set of containers that are going to reuse the exact same data as I was explaining, but you don't upgrade this time. You just do, it's another application, which is a clone of the existing application. This allows you to do anything you want without any chance of damaging the running cluster you may have already. So we do all this on top of the standard Kubernetes that we also expose. So if you have some Kubernetes knowledge in-house, you can reuse that knowledge. So we usually ask, but what if I wanted to do this by myself? Well, that's potentially something you could try. However, like everything else, there's the potential for a difference between the desired result and what you actually end up with. And that's why we provide all these features and all these extensions on top of Kubernetes. And again, I want to emphasize, we do not modify Kubernetes under the covers. We reuse the standard Kubernetes, unmodified, 100% unmodified on purpose, we simply add next to Kubernetes pieces that allow us to do what we do. This is very important because sometimes we get the question, but what if you modify Kubernetes? Who's going to support the modified Kubernetes? Well, we're not modifying it. So anything that the Kubernetes community is going to do and put out there, we're going to have because we reuse exactly the same Kubernetes under the covers. However, we add these extra pieces next to it that don't exist in the Kubernetes project. So what is Robin? Robin is a hyper-converged Kubernetes platform to run all these workloads. So big data, I talked a little bit about that. We can also obviously run Spark. Databases, because we can run stateful applications, because we control the network and the storage layer. The database, by definition, is a stateful application. It's its job to keep track of the state of the data you put into it. So we can run any kind of database engine you can think of, all the oracles in the world, Mongo, Cassandra, MySQL, Postgres, you name it, we can run those. And we can also run AI and machine learning workloads, obviously. And we also can run, if you want to, an existing application that you wrote in-house 5, 10 years ago. And the way we do this is by creating a Docker image from your servers the way they should be installed with your application and all the pieces. And we're going to set up that new Docker image in your own local Docker image repository, so you can run your private Docker Hub, Artifactory, whatever you want to use, so that only you have access to that new image, and you can reuse that as an input to the system so that you can now containerize without having to rewrite the whole thing. You can containerize an existing stateful application that you wrote 10 years ago. And you can put it into containers like everything else, and now it's just another one container running on top of the Robin platform. So here's a couple, actually more than a couple, but a few data points of what we currently have with existing customers. So just to give an idea of the kind of performance we get, and we get that kind of performance because we don't have a hypervisor, right? We write to disk directly. We do not use some kind of file system in between. We directly access the disks at the block level. And that allows us to have really, really good performance for tools like Kibana, Kafka, especially Kafka that needs performance to be able to do its job streaming. And that allows us to run 11 billion security events ingested and analyzed a day for that specific customer. We also have customers storing 6 petabytes of data directly in a Robin cluster. And we also have customers running Oracle RAC databases. I forgot to mention that, but we can also run Oracle RAC on a Robin cluster. So we have a customer running 400 Oracle RAC databases right now on Robin. So quickly, what's the software stacks? At the core, we put Kubernetes, standard Kubernetes, unmodified. I know I'm repeating myself, but this is very important because we don't want ever to modify Kubernetes because we don't want to own whatever change we may introduce into a standard Kubernetes. We want to reuse the exact same standard open source Kubernetes on in the community. We add a layer to manage the storage. So what that means is we intercept all the reads and writes from the containers themselves, and we are going to redirect those either to local storage devices, SSDs, or spinners, your choice, or to remote storage if you allow it to go remote. And obviously, we're going to have to push the data over the wire in between the nodes. That's obviously obvious. But this allows us to override all the different mount points and volumes that are configured for a given container. So including, especially, the root file system, the one mounted on Slash on Unix. And this way, we can guarantee that we can run stateful applications, because when we restart, or more precisely when we ask Kubernetes to restart a pod that contains the container that runs whatever application you might be running, we're going to rewire the entire storage layer. So all the data that was stored on disk is actually visible when you reboot the container. And this is fundamental to being able to run stateful applications. The other piece that we're adding is this virtual networking layer. And today we support either Open vSwitch or Calico. It's your choice. If you use Open vSwitch, you're going to use real IP addresses, meaning that they are visible and routable from the outside of your cluster, from a client, client application, client machine, whatever that is. You can use the IP address of the container if you decide to go with OVS to wire those IP addresses to the containers. And if you go with Calico, you're going to have an overlay network that is going to use its own range of IPs that are not visible from outside of the cluster, and you're going to have to do the port mapping slash find the IP address of the host running my container thing, like everybody else with Calico, with one difference. The Robin software guarantees that the port mapping is going to stay exactly the same for the entire lifetime of an existing application, thus a container, which means that if you're running, for instance, a Postgres database that wants to listen on 5432 and it gets mapped to 20,001, it doesn't matter what node that Postgres container runs on, even if it gets rescheduled on another host, we're going to guarantee that its port mapping will still be 20,001. The only thing that's going to change in this case is going to be the IP address or the name of the host running the container. And then at the top, we have our application workflow manager, which is basically the Robin code that glues all these pieces together. And that also provides a UI, which is web-based, so use your standard browser. And we also provide what we call bundles. And those bundles allow us to offer an app store-like experience where you have the choice of all the different applications that your administrator has given you access to. And you can select, I want to run a Cloudera cluster, I want to run a MySQL, I want to run a MongoDB with 5 shards, I want to run something else. You click on it, and you get presented with a config page with a bunch of default values already entered for you. You can override them if you want to, or you can accept and simply say deploy. And we run on bare metal, obviously. We can also run in virtual machines if you want to do that. And we can run in the cloud with the 3 main providers out there. So what's this App Store experience I'm talking about? So this is a screenshot of what it looks like. You select whatever application you want to run with, and then you're going to be presented, in this case this is Hortonworks, you're going to be presented with a configuration page where on the left side you have all the different services that you can turn on and off depending on what you want to do. And if you turn them on, you're going to say how many instances you want, i.e. how many nodes, which are going to be mapped, each one to a separate container. And you're going to define how many resources you give to these nodes, how many CPU cores, how much memory. And then for the storage portion, you're going to say these different volumes pre-configured in the bundle itself. The bundle is basically a YAML file with a bunch of scripts. You're going to say, I want to give it 20 gigs, 50 gigs, 200 gigs, 500 gigs, whatever makes sense. You're going to say if I want SSDs or HDDs. Then when it comes to the parameters, you can also, depending on what it is, these parameters can be completely different. If you're dealing with a MySQL database, this is going to be, give me the password that you want me to set up by default for the admin, MySQL admin. If this is a Postgres, something equivalent, maybe some environment variables you want to pass. Whatever makes sense for whatever service or application you're about to deploy. And then we have placement rules. So those placement rules allow us to define affinity and anti-affinity rules where you can say, I want this to happen in terms of placement, or I don't want this to happen in terms of placement. So you can do things like Zookeeper, do not run all my Zookeeper containers on the same host or on the same rack, because I know that if I lose the node, if I lose the rack, I'm going to have a problem if all my Zookeepers are gone. So you can this way define what you want or don't want so that the system knows. And then at the very top, obviously, you need to give it a name. The resource pool is just a way for you, for an admin, to group hosts into logical pools. So because we also have the concept of multi-tenancy, you can say tenant 1, you're only allowed to deploy on nodes belonging to resource pool number 1. Tenant 2, you're only allowed to deploy on nodes belonging to resource pool number 2. So depending on how you want to organize your machines, your tenants, who has access to what, you can control this with resource pools. The IP subnet is actually allowing us to select an IP pool. So we're going to tell, an admin is going to define those pools. And we're going to tell the system, when you deploy those containers and you need to give them an IP address, grab those IP addresses from that pool. And in the config page, which I don't have here, your admin is going to say this IP pool uses Calico, this IP pool uses OVS, and those are the ranges that this IP pool is allowed to use. And once those are configured, they show up on that page. And same thing, your admin can say, tenant 1, you're only allowed to use these IP pools. Tenant 2, you're only allowed to use those other IP pools. Or maybe you can share. So once you are satisfied with all the different parameters, you can ask the system to deploy, and it's going to do all the job for you. So it's going to first make sure it has the resources on the hardware that you gave to it to actually grab whatever it is that you want allocated in terms of memory, in terms of CPU cores. And then it's going to solve the puzzle of those placement rules that you gave to it by saying, I want this, I don't want that. And if there is a solution, it's going to find the solution, and then it's going to start deploying and running scripts under the covers to pre-configure and pre-wire everything so that at the end, whatever application you ask for is ready for use. So this is just a quick zoom in of what this left column is about. As you can see, some services obviously are must-have, so there's not an option to turn them off, like a data node. You need some HDFS. Zookeeper is also, although it's not showing here, is also mandatory, so you cannot turn it off. But other than that, Hive, you may or may not use it, so you can turn it off if you want to. Then here, it's showing you exactly what it's telling you, which is that you can specify how many resources, how many instances you want to give to your service. And those placement rules allow you to define, I want this, I don't want that in terms of placement. And this allows us to provide this App Store experience where end users can get access to a brand new application on their own, thus liberating your sysadmin, your DBAs, and whoever is usually taking care of installing software, configuring, finding a server, I need to wire the network and to ask IP addresses from my network guys, etc. You can now give access to your end users within control, within limits, because you can say you can do this, you cannot do that. We have the concept of multi-tenant. And that allows us to provide a ton of value because now you can consolidate workloads, so you use your hardware a lot better. You remove all the limitations in terms of time to get to something up and running. Because now with the UI, you get a full-blown application ready to use in minutes instead of potentially weeks. And finally, all your sysadmins, your DBAs, whoever is taking care of that today, you can now free their time up for other tasks where they can focus on doing other things other than just copying an Oracle database or setting up yet another Oracle database or setting up another Hadoop test cluster for someone to run something for a week, and then you take it down. You just give access to your end users and they can do this on their own. So lifecycle management is once the whole thing is set up and is running, what can I do? Well, you can do a few things directly in the UI without having to ask your admins to do it. You can scale up and down, meaning create new containers or remove existing containers. And we're doing it the right way, meaning that we spin up the containers, obviously, but we also run scripts to let the new containers know that they need to join an existing cluster of something, for instance, so that the whole application is aware that now it has more resources. You can also, so that was for scaling out. You can also scale up an existing container. So if you know that your Hive metastore that you store in MySQL is a bit short on CPU and memory because there's a lot of demand, you can, on a running container, say, give it more memory or give it more CPU cores, and we're just going to do that directly from the UI. You can also control the quality of service. So because we intersect all the reads and writes, we can cap the I/O per second that a given container is consuming for a given volume. So this way, we can solve the noisy neighbor problem that you can get potentially when you run multiple independent applications in independent containers on the same machines. Virtual or physical, doesn't matter. If one of these starts grabbing all the I/O resources, everybody else is going to starve. We can control that because, as I said, we intersect reads and writes, so we can count them, so we can put a cap. So those are some of the screenshots that show what you can do. You can also create a schedule to take snapshots of an application if you want to do that for whatever purpose, as a way to be able to go back in time if something wrong happens. You can also have upgrading bundles where the bundle itself is containing all the instructions to upgrade a running application of version X to version X+1, for instance. And you can test those upgrades using the cloning feature I told you about. So the benefits, depending on your profile, why would you want to use Robin to run your different applications and containers? If you are talking about operations, you're going to simplify everything. And you're going to be able to increase the utilization rate of your hardware, obviously, because you consolidate. You also can guarantee SLAs and uptime, because we also have a lot of HA and GR mechanisms I didn't look into today, where you can guarantee that if something goes down, it's going to be rescheduled. Even if the entire node where those containers were running went offline for whatever reason, motherboard just fried, they're going to be rescheduled onto another node directly, automatically by the system. If you ask for the data to be replicated by Robin, or you were running an application that knows how to do it on its own, like HDFS, then we know we have a copy of the data somewhere else. So when we reschedule the pods, we're going to rewire the storage to the copy of the data, so this way they can be restarted and be happy and find everything they were expecting on disk, and they can be running again. And obviously, it's a very profound move right now that's happening in the market, where everybody is moving to containers because of all these value-added features, especially compared to virtual machines, which is a concept that's 20 years old, where you now have everything in containers, on-prem, in the cloud, and you just move stuff around by asking the system, move this to that node or move this to that other node. And if you work in development, and you want to apply all these agile concepts, now you can fully have a fully automated way of doing your all CI/CD pipeline directly by using, I didn't tell you about that, but we also offer a REST API or command line. So if you want to script, if you want to use the REST API, we also provide access to kubectl, because we still have standard Kubernetes under the covers. We also provide access to Helm charts if you want to use those. And you can fully automate the entire process. And we have a customer that's doing just that. They automated the entire thing. So every time a developer commits something into their local GitHub, it triggers, obviously, a build, automated build. And then before they run the different testing, what they do is they call Robin and ask Robin, hey, deploy these containers for this application. I'm going to push this build into these containers, and I'm going to run my test, my automated test, directly on those containers running my new build, and then I can report on the results. Fully automated. And that's it for today. So thank you for listening to me. So maybe we have some time for some questions.
Yeah, we sure do. Yeah, great presentation, Patrice. Very cool stuff. I'm going to go ahead and pop up this poll question for the audience and just leave that up there while we do some Q&A. The question is, what's your time frame to refresh or update your data center? compute and/or storage infrastructure. So, Patrice, one question here Richard is asking, is there a stateful API for the Robin system solution?
Yes, we provide different ways of interacting with the system. You can, as I said, use the UI, which is typically how people start because it's easy. And if you want to script something or automate, obviously you need access to the system directly. So we provide a command line, so a CLI, your typical CLI with all the options in the UI are accessible directly from CLI. So if you want to run a shell script, you can also use our REST API if you want to do that, same thing. And by the way, the UI and the CLI both call the REST API under the covers. So anything you see in the CLI or anything you see in the UI, this is actually converted to a REST API call, which means that the REST API is actually the right way to interface with our system if you want to get into the low level of how the thing is orchestrating. The other two entry points we provide are kubectl, and if you want to use a Helm chart to deploy something directly on Robin, we can do that too.
Okay, very nice. Another question here, they're asking, can I use the hyperconverged Robin solution?
Yes, we actually have people who do that specifically because, I'm not going to give names obviously, but there are many, many prospects and customers who love the concept of the cloud, meaning the agility, technical agility obviously, but also business agility, right? You heard that your competition came up with a super cool machine learning way of doing something, and now you need to catch up and you want to test something quickly, right here, right now. Well, you can obviously spin something up. Problem is, the cloud, people don't want to put that data in the cloud for different reasons, especially if you talk to financial services, insurance companies, anybody who has some kind of very, very large potential risk associated with being hacked and having data stolen. Everybody is extremely careful before they put their data in the cloud. And so all these people I'm talking about, they are in a situation where they love the concept of the cloud. Spin something up in minutes, scale up, scale down, tear it down, share resources, etc. But at the same time, they don't want, or they cannot. It's legally such a nightmare that the lawyers say, you're not doing that. So what do? They look at building their own private cloud. And we have customers who did just that with Robin, where, well, guess what? You're not going to use the typical cloud that you've heard on different websites. You're going to use our own in-house version of it that's actually using the Robin UI. And we're going to give you access to all these features where you can do what you want within limits, obviously, as I was saying. You can control what your different tenants are doing. And this is how they implement their own private cloud solution.
Very nice. And then another question here, can you run any database engine in containers on Robin?
Yes. So this is a big one. One of the big reasons why people go with Robin instead of trying to use Kubernetes/Docker directly themselves and putting all the glue that we put together over the last 4 years. The typical database engine, by definition, is a stateful application, meaning that, especially if you run something like an Oracle database, if you try to shut down an Oracle database cleanly or not, and then you change the IP address and try to restart it, I guarantee you it's going to start complaining a lot. So you cannot do that, obviously, in containers. We can run an Oracle database in containers because we control the storage, we control the network, we control all the different little pieces in between. So an Oracle database can save its data, and its data is going to be given access, its data files, or even ASM storage if you want to do that. It's going to be given access directly to the spindles like any other block device. And after that, the blocks are stored outside of the container. So if the container needs to be restarted or moved around or whatever, we're going to rewire the storage layer. We're going to rewire the exact same IP stack. And when you restart your Oracle database, for instance, in your container, it's going to just restart because it found all the data it was expecting on disk, and it finds the network config it was expecting. So any kind of database, which are stateful applications, can be run in containers on Robin.
Very nice. And then a final question we probably have time for here is, how do people typically get started with Robin? What's the first step?
So the first step is usually to talk to either someone like me who does the sales engineering, or to talk to one of our sales executives. And we usually start by having maybe a more detailed presentation. We talk about the use case. We talk about the objectives of what people are trying to achieve. And then we also do a demo, because we have test clusters, obviously, internally that we can use for demo purposes. And then if everything makes sense for everybody, we usually have a POC that we frame usually around 2-3 weeks. We frame in terms of use cases. We also define exactly what people want to test, what applications they want to test, their success criteria, and we execute on the POC.
Very nice. Very nice. Sounds easy. Well, I think that's all the time we have, but really great, really amazing presentation. Thank you so much for being on the event today, Patrice.
You're welcome.